We'll move on to our next presentation. This is land-based nutrients effect on duration and intensity of red tide events, presented by Dr. Miles Medina of University of Florida Center for Coastal Solutions. The purpose of this is to provide findings from a recent study to identify systematic cause and effect relationships between red tide and anthropogenic drivers. The CCMP connection relates to Water Quality Improvement Action 5, reducing HABs, specifically Activity 5.1, supporting HAB research and monitoring and measures to reduce their environmental, social, and economic impacts through ID and reduction of anthropogenic influences. Please take it away, Dr. Medina.
All right, thank you. It's a pleasure to be here, and thanks for inviting me to speak with you today. I'm Miles Medina, and I'll be presenting some of my recent work linking red tide blooms to near Charlotte Harbor to nutrients and discharges from the Caloosahatchee River. Next slide. Okay, so this video on the left shows red tide data near Charlotte Harbor from about the last 10 years, and these are the data that we used for our analysis. In each frame, you see samples collected in the area during a 2-week period. Each dot represents a red tide sample, and the size of the dot corresponds to the amount of red tide in the sample. So blooms show up as clusters of red dots. And while that continues to play, I'll give some background information, just recalling some things that Dr. Hubbard just went over. So the red tide organism, Karenia brevis, is a type of phytoplankton, meaning that it does photosynthesis like plants, but it also requires nutrients from the environment. And as Kate indicated, it's not a picky eater. It can use nutrients in a variety of forms, including organic and inorganic nitrogen. And of course, in terms of impacts on us, these blooms are concerning because they're associated with economic costs, particularly to the tourism and real estate sectors, as well as public health problems and ecological damage and wildlife mortality. So let's just let the video keep playing. It's almost done. And the question I'm concerned with is what causes these blooms? So let's go to the next slide. Okay, so as Kate indicated, there are both natural and anthropogenic, potentially anthropogenic drivers here. It's well known that the blooms occur naturally. And research has shown that blooms start offshore due to natural processes. Ocean currents and circulation patterns can set up a sort of conveyor belt that moves the bloom to the coast. And then once the bloom is on the coast, it can be maintained and intensified by local nutrient sources, which might include nutrients that ultimately come from our cities and farms. And this is the last part that my research focuses on. The big question is whether we're making these blooms worse. And I think it's an important question because on the one hand, we can't do much about the natural causes of blooms. Like we're not going to change ocean currents in the Gulf, but we can perhaps do something about our own influence on these blooms if it turns out that we're having a substantial impact on how long the blooms last or how intense they become. So this kind of research can hopefully point towards sort of mitigation measures that we can take to try to, at least to some extent, reduce the severity and the duration of these blooms. Okay, next slide, please. So let's dig into this question a little deeper. First of all, we know that it's possible, it's physically possible that humans are causing these blooms to become more intense. We know that the Karenia brevis organism can use the forms of nutrients that we put out on the coast, nitrogen, phosphorus, and so on. We also know that the amount of nutrients we're putting out has increased over the past couple centuries as our population has grown and land use has become more intense. And finally, we know that the amount of nutrients that we're putting out can meet a substantial portion of the bloom's nutrient requirements. On its own, the nutrients we put out aren't typically enough to sustain a bloom, but they can make up a substantial enough portion to be concerned about. So it's certainly plausible that we could be making blooms worse. Now, researchers have also looked at the data to see if there's a link between human activity and blooms. And here the results have been mixed. So on the one hand, there's often a correlation between blooms and river discharge, that is the amount of water coming out of a river. but there hasn't been much evidence of a correlation between blooms and the nutrients coming out of these rivers. So is that just the end of the story? Is the answer, if we don't see a correlation, does it mean that our impact must be too small to really worry about? And I would argue that the answer is no, not necessarily. So this reminds me of this old story that comes along in different comic strips and stuff these days. It's about a guy looking around for his wallet under a lamppost, and someone comes along and asks if this is where he lost his wallet. And he says, no, but this is where the light is good, right? So this is where I can see. And so this problem is really common to all of science. We're always limited by the information and the data that we have available and by our ability to ask and answer the right questions. So what I would say about this correlation issue is that the real question we're concerned with, whether humans are making these red tide blooms worse, is fundamentally a question about causality. So let's talk about causality and correlation for just a minute. Next slide. Okay, so we all know that correlation doesn't mean causation, right? Two things can be correlated, but maybe they're completely coincidental and they're not actually physically related to each other. But less well known is that the opposite is also true. So a lack of correlation doesn't necessarily mean that there is no causality. It is possible, for example, that land-based nutrients influence red tide blooms, even though the two aren't correlated. So how can this be the case? Well, correlations represent a very simple type of relationship. For instance, a correlation between nutrients and blooms might mean that more nutrients leads to more blooms. But we know that this is a complex system and there's a lot of different processes and interactions going on here. So the interaction between nutrients and blooms might actually be quite complicated and what we call state dependent. That is, whether and how nutrients affect the blooms can depend on other factors and other conditions being met. So the same amount of nutrients being put out on the coast might have different effects on blooms at different times, depending on what else is going on in the system. And this can all manifest as a lack of correlation, even though there's a causal mechanism there. Fortunately, there are methods available for working out causal relationships in the context of complexity. And I'll just briefly describe one of the core concepts here, which is the idea of phase space as pictured in panel B. The idea is that the behavior of a variable over time, for example, the behavior of blooms, can tell us about the interactions that occurred during that time. We can visualize the patterns of behavior of different variables as this type of geometric object that you see in panel B. This is called a phase space manifold. And we can examine the shape of this object to learn about the causal interactions between variables. The important thing to understand here is that this way of analyzing the data automatically respects the complexity of the causal relationships. And so it transcends the common limitations that you face when doing a correlation analysis. Next slide. So in 2020, I published a paper using phase space methods to link red tide blooms near Charlotte Harbor with nitrogen inputs from the Caloosahatchee River. And this was perhaps the first empirical evidence of an anthropogenic link in this area. The work showed, first of all, that blooms exhibit a strong signal that represents a systematic pattern of behavior. This is shown in red against the data in black in the time plot on the right. So this systematic pattern of behavior implies that there may be systematic cause and effect relationships at work. And indeed, we investigated those to find a link between blooms and nitrogen inputs from the Caloosahatchee River by investigating the phase space manifolds, also shown on the right. So these results were pretty novel and interesting, but they left a few questions unanswered. And this is the subject of the work that I've just completed and that's currently in peer review. Okay, next slide. All right, so the 2020 study showed us that Caloosahatchee River nitrogen influences nearby blooms, but what we're really interested in is whether nitrogen is intensifying the blooms. That is it making the blooms worse? So this is our first hypothesis. We look at the relationship between blooms near Charlotte Harbor and conditions in the Caloosahatchee River at station S79. And next, if the answer to this first question is yes, that discharges and nutrients from the river are intensifying blooms, then we want to know how much of the watershed is involved in contributing to these blooms. So the question is, can we trace this influence further upstream? And we investigate the second hypothesis by essentially walking upstream from the Caloosahatchee River Station, S79, to the Lake Okeechobee Station, S77, where water discharges from the lake to the Caloosahatchee, and then up to the Kissimmee River Station, S65E, where the Kissimmee River discharges into Lake Okeechobee. And we look for causal relationships between each pair of stations. We focused on the Caloosahatchee River, Lake Okeechobee, Kissimmee River flow path, since this is the major flow path in the watershed. And also because we're just limited by data, these are the areas with enough data to support this type of analysis. So it's worth mentioning that other basins, the Myakka River, Peace River, and so on, are also important parts of this watershed. And as you can see on the map on the right, the dots represent red tide samples during our study period. Those are the red dots on the coast. And then we've got the Huc 8 boundaries. The colors indicate the land uses. So in gray, we have urban and residential areas. In yellow, we have agricultural areas. And then the stations S79, 77, and 65E are marked by blue triangles. Okay, next slide. All right, so I won't spend too much time on the methodology, but this is a picture of our workflow for analyzing the data. We start off by taking monitoring data and organizing it into time series to show behavior over time. And then from these time series, we can recover signals that represent systematic patterns of behavior and construct those phase space manifolds. And then finally, when we obtain signals, and manifolds, we can use them to run causal analyses to detect and characterize systematic causal relationships. Okay, so let's move on to the results on the next slide. Okay, so first of all, we found that between 2005 and 2021, red tide blooms showed a strong signal or systematic pattern of behavior, and this is shown in red in panel A. And as you might expect, the signal is predominantly seasonal. Panel B shows the phase-space manifold. So this is kind of very similar to the results from the 2020 study, just over a longer period. Next slide. Okay, likewise, we recovered signals from the Caloosahatchee River discharge and nutrient data. So we have discharge, specific conductance, nitrogen, and phosphorus at the S79 station. As you can see, the phase space manifolds each show an organized structure that indicates systematic patterns of behavior in these variables. And we also run these through some diagnostics to quantitatively test for the kind of structure that we need to justify doing the causal analysis. Okay, so we're ready to move on to the causal analysis and see whether what's coming out of the Caloosahatchee River affects nearby red tide blooms. And looking at the data from 2012 to 2021, so nearly a decade, we found that blooms near Charlotte Harbor were systematically intensified, influenced by nitrogen and by discharge from the Caloosahatchee River. There were some interesting time delays detected in these relationships, and I won't have time to get into those. In contrast, we did not see evidence that phosphorus or specific conductance systematically affected the behavior of these blooms. So we saw a causal relationship for nitrogen and for discharge, but not for phosphorus or conductance. And finally, it's worth pointing out that this analysis included tests to ensure that we're not mistaking mere coincidence for causality. That is, it's possible that the results are just coincidental since, for instance, nitrogen and bloom cycles are both seasonal. So we ran it through this kind of scrutiny, and the results showed that indeed it's a causal relationship and not just a coincidental finding. Okay, next slide. Now going a bit deeper, the next thing we want to know is about the nature of the relationship between blooms on the one hand and Caloosahatchee River nitrogen and discharge on the other. The analysis indicated that discharges and nitrogen both systematically intensify coastal red tide blooms, as shown in panel A, where you can see both curves are strictly positive. The blue curve represents the influence of discharge on blooms over time, and the black curve represents the influence of nitrogen on blooms. Further, we found that while discharge and nitrogen both consistently intensify blooms, when these effects are their strongest depends on what stage the bloom is in. So the effect of discharge was typically strongest early in the bloom cycle, and the effect of nitrogen was typically strongest later once the blooms were in the maintenance phase. So this implies that the water coming out of the river may actually affect blooms both as a carrier of nitrogen and through a separate mechanism. For instance, it's possible that large discharges can change the circulation patterns around Charlotte Harbor, and they might actually draw red tide water in from the Gulf. So this is a subject of ongoing modeling and research, but it's a possibility. On the other hand, nitrogen seems to play its most important role in maintaining, intensifying, and therefore prolonging blooms. So it's not to say that, anthropogenic forcing is what causes blooms, like it's the one smoking gun, but the evidence suggests that it's playing an important role in the intensification process. Okay, next slide. All right, so investigating our first hypothesis showed us that nitrogen inputs from the Caloosahatchee intensify blooms, and then moving on to our second hypothesis, we want to know whether this influence can be traced upstream to Lake Okeechobee and to the Kissimmee Basin. And indeed, the causal tests indicated relationships upstream. So the behavior of nitrogen at the Caloosahatchee is influenced by nitrogen at Lake Okeechobee, that's station S77, which is influenced by nitrogen at the Kissimmee River, station S65E. All right, so to summarize, we have this causal diagram on the left showing the influence of nitrogen from the Kissimmee Basin to the lake, and then to the Caloosahatchee River, where nitrogen inputs and discharges to the coast ultimately intensify red tide blooms. Next slide. So just a couple of bullet points, takeaways here. So we found nitrogen-enriched runoff from a vast and highly developed watershed consistently fuels Karenia blooms near Charlotte Harbor. This has implications for management, of course, maybe treatment wetlands and other kind of nutrient management methods can reduce the nutrient load and the effect on bloom intensification. We saw how correlations do not reliably capture this anthropogenic link. The timing of the Caloosahatchee discharges and nitrogen inputs relative to a bloom stage of development is important, might be as important as the actual amount of discharge or nitrogen. Discharges of nitrogen may act on blooms through distinct but synergistic mechanisms. And mitigating bloom intensity and duration will likely require holistic solutions that consider both natural drivers and anthropogenic drivers and how they interact. Finally, ongoing work at the Center for Coastal Solutions includes identifying subbasins and land uses that contribute the most strongly to blooms, modeling alternative Lake Okeechobee operations, and proposing changes to reduce impacts on the coast from discharges. And finally, simulating hydrodynamics around Charlotte Harbor in 3 dimensions to understand how Caloosahatchee discharges affect tidal exchange and circulation patterns in Charlotte Harbor. All right, next slide. So here's my contact info. I'd be happy to share either manuscript with you. One of them, like I said, is in peer review, but I can share a copy of that draft. And we have the UFCCS website here. And with that, I'd be happy to take any questions.
Thank you, Dr. Medina. Are there any member questions that you'd like to share? Have a question from Phil. Do you want to come off mute, Phil?
In case he doesn't have audio, I'd be happy to restate it. Oh, there he is.
Yeah, I wrote what I was thinking, there's a lot of focus on, there's always a lot of focus on the Caloosahatchee. These blooms can occur off Tampa, like in 2005 when we had storms, that flushed nutrients through rivers, probably influenced the 2005 red tide, so just wondering, what the authors think about, looking at other river systems.
Sure.
Anything
Yeah.
that-
Yeah. It's a great question. Certainly it'd be interesting to look at other watersheds and rivers as well. This kind of analysis, it's it's kind of intense, and so you want to limit the spatial scope to a relevant area, like one area at a time. You may have different drivers in different watersheds. With regard to this watershed, like I said, there's the Peace River, Mayaca River, the two other main rivers here. And while those are important contributors, and likely also contributing, to bloom intensification, the main constraint we had is just the amount of monitoring data. So the South Florida Water Management District collects data frequently enough and has collected it consistently enough to do this kind of analysis. It kind of requires a lot of consistent monitoring to do this type of work. So unfortunately, we couldn't include the Peace Mayaca in this analysis, but it would have been interesting to do so. But it's worth noting, of course, that Caloosahatchee is a big input, especially considering discharges from the lake, and that's a big sort of management question. So yeah, that was our focus here. But by all means, I mean, we're actually working on doing something further up the coast as well.
I got a question here. My name is Ernesto Lazo de la Vega. Great job, Miles. This is an absolutely great presentation. Very complicated, but you make it sound so simple. Oh, I know it's complicated. Could you go back to the slide that is the summary? Because I have a question there on your summary slide, which I thought was very simple and great. No, the one before. Yes, that one. What is the Q on the bottom? It says, and that's my only question is like what the Q is stand for on that. Was that?
Yes. Yeah, sorry about that. And thanks for the kind words. The Q is discharge, river discharge.
Oh, quantity. Okay. Okay.
Yeah.
Oh, excellent. All right. No, that was just a simple clarification question. Thank you.
Okay, sure.
Thanks, everybody. It looks like it's about time in our agenda to move on. Dr. Medina gave his contact information there. If anybody has further questions for him, please feel free to reach out or, through the chat of this meeting, you can grab them real quick. Much appreciated, Dr. Medina. Thank you.